All right, thank you. Hello everyone, my name is Clara Blum, and today I have the pleasure to present you our work Breakpoints in Data Continuity across construction reuse projects. This work was conducted at the Lab for Circular Engineering for Architecture in collaboration with Silvia Vangelova, Kasimir, Jens Hunhevicz, and Catherine Wolf at ETH Zürich and Empa. Reuse is increasingly recognized as a key strategy for circular construction. However, many reusable materials remain unused. As Lucas already mentioned, elements from source projects move through deconstruction, transport and storage, planning, and reconstruction, and we repeatedly observe that material information is lost. Much research exists in logistics and digital representation. However, there is limited empirical understanding of how these infrastructures interact or fail to interact as materials move between projects. So we asked ourselves, as materials move from one project to another, where and why does material data continuity break between logistics and design in reuse-oriented construction life cycles? And to answer this, we defined a framework and so-called breakpoint classes of discontinuities between the framework components, and then applied these across 8 reuse case studies to provide empirical insight on where and why material data continuity breaks down. Our starting point was the observation that reuse projects operate through 2 separate digital ecosystems, logistics and design. The logistics side focuses on tracking and inventory management, whilst the design side focuses on digital representation. Both describe the same physical materials, but often use different and disconnected identifiers, databases, and workflows. And our hypothesis was that many reuse problems emerge precisely at the interface between these 2 systems. So rather than treating logistics and design as separate data domains, we propose a shared framework that integrate both. And this revealed 6 recurring classes of breakpoints, ranging from physical-digital interface failure to inconsistencies between identifiers and disconnected data repositories. Each covers different discontinuities between components of this framework, which result in identity loss during reuse processes. For one, the loss of connection between a physical element and its data carrier. So when elements are cut or transformed during reuse, the carrier may be removed or damaged, making the element's identity and data inaccessible. Further, we find mismatches caused when we switch between instance and type level IDs. So when elements are grouped under one generic identifier, individual components can no longer be clearly distinguished or traced. Another obstacle describes where the data carrier remains not readable through the user interface. So if the carrier is damaged, worn, or degraded over time, access to the element's identity and the stored data is lost. And if the carrier cannot be adapted over time, so changes to the element's ID or data may not be reflected during reuse, which also addresses the absence of long-term maintenance and access control mechanisms, highlighting also governance-related challenges for material passport systems. And one core breakpoint is also cross-system ID inconsistencies, so when the same physical element has different IDs across systems. Its digital and logistical records and their coordination become difficult to align. And lastly, the problem of unlinked IDs and model storages. So if both systems store related data separately, updates become duplicated and remain manual coordination whenever changes occur. We then applied this framework to 8 reuse case studies conducted in the past 5 years at ETH Zürich with materials sourced from 3 deconstruction projects. The 8 case studies are all temporary structures built at our lab, which also facilitated data access and allowed for interviews with colleagues involved in the processes. For each project, we reconstructed how materials and information moved through the reuse processes and documented where breakpoint events occurred. And we found that the highest occurrence was in cross-system ID inconsistencies and unlinked data repositories, followed by physical-digital interface loss and ID granularity mismatches, and static carrier limitations. So carrier degradation was not present in case studies analyzed here. Overall, material identities were repeatedly detached from their physical element when elements were transformed, and when identifiers were reduced from instance level to type level ID, or when information became distributed across different disconnected systems. Inventory systems and digital design models increasingly describe the same material in different ways, requiring manual coordination and limiting digitally integrated reuse workflows. This also suggests that one primary barrier to reuse is not the absence of digital tools, but the absence of synchronizing the identifiers across design and logistics. Today, materials survive multiple life cycles, whereas their identities often do not. And this study investigated where and why material identification and digital representation fail to persist across reuse life cycles. We first proposed the framework that integrates logistics and design infrastructures within a shared infrastructure, and then defined these recurring breakpoint classes to make these discontinuities between the infrastructures explicit. And third, we demonstrated these breakpoints empirically across 8 reuse cases and used them to derive recommendations for continuity-oriented digital infrastructures. The goal of the study was not to evaluate a specific technology, but as we know, the construction industry already has sophisticated digital infrastructures. But the problem is that they're developed independently. So this paper provides a systematic way to analyze these discontinuities between them. Across all breakpoints and use cases, one aspect dominated, the identifier. And even though all components of the framework are important to retain identity, the identifier builds the central anchor to ensuring the interface between physical materials and all digital representations. This is also a small outlook to the following presentation, where we'll look at a first solution proposal for 2 of the case studies presented. With this, I'd like to thank all contributors and funding partners and you for your attention. Thank you very much.